So today we'll be looking at lesson 6, applications of the trig ratios. And our main goal is to solve word problems that involve right triangle relationships. And we'll be applying the 180 rule, the Pythagorean theorem, and the 3 trig ratios. And we'll explore it by looking at 3 of the examples in your booklet. Well, let's recap what we've done so far. So we looked at the 180 rule. We looked at the Pythagorean theorem. And just to recap, the 180 rule states that in a triangle, the three interior angles are always add up to 180 degrees. The Pythagorean theorem states that in a right angle triangle, the square of the adjacent plus the square of the hypotenuse, plus the opposite is equal to the square of the hypotenuse, or a squared plus b squared equals c squared. And finally, we look at SOHCAHTOA, the trig ratios. So we can use the trig ratios to find a missing angle or a side when we're given 2 of the properties of the right angle triangle. So let's look at question 1. Question 1 states that example 1, we have Kyle stands 8 feet from the base of a streetlight. The angle of elevation from the ground to the top of the streetlight is 75 degrees. What is the height of the streetlight? Now, a couple of things I want to review first before I go into this example. I want to look at what is angle of elevation. And we'll look at each one of these questions and look at angle of inclination. I'll just go back to the 3 questions overall. The first question, talk about angle of elevation. And then the next question refers to angle of inclination. And the third example looked at angle of depression. So I would like to review each one of these before I go into the questions here. So let's look at what we mean by angle of depression. Now, angle of depression, and this is critical for you to know, it's also related to angle of depression. I will see it's also related, angle of elevation is also related to angle of inclination. So the angle of depression is a downward angle from the horizontal line. So if you were looking, if this is you and you're looking straight horizontal, this is horizontal line. So this is your eye. Think of this as your wonderful eye here. So this is your horizontal line. So your angle of elevation is from this horizontal line going upwards. So it's elevating. It's like an elevator. Something is going upwards. Your angle of depression is from this horizontal line or your point of view, horizontal point of view, going down. So it's angle of depression. So think of elevation. So it's always from your eye vantage point. So this is your eye here. And from where you're looking straight horizontally. So more specifically, if I were to look at angle of elevation, you're at the ground level here. So you want to look at the top of the tree. So the angle of elevation is from the ground. So just imagine your eye is somewhere here. This is your eye. So you're looking upwards. So it's from this is horizontal point of view here, same as what we have up here. This is your ground level, horizontal line. So your elevation is actually the angle is going up. So it's always, think of it as elevating angle of elevation, like you're rising. So the first question, looking at the angle of elevation. So let's go back to that question. So Kyle's 8 feet from the base. Just imagine this is your street light here. And this would be your ground level. assume the street light is the post of the street light is straight. So here we have the street light. This would be the post, right? And it tells us here the angle of elevation from the ground. So we're looking at here. So this would be your eye. So angle of elevation to the top of the street light is 75 degrees. So this is your angle of elevation to the top. So the street light is here at the top of it. So draw a straight line. Oops. Okay, let's imagine it's here, top of the street light. So this will be my angle of elevation. Tell me it is 75 degrees. Now, we have to make this 90 degrees because we're assuming the street light is perpendicular to the ground. So this is my ground here. Now, tell you that Kyle stands 8 feet from the base of the street light. So this is the base of the street light, and he's standing up here. So this will be 8 feet. And it would like to find the height of the street light, how high the street light is. So let's move this guy here. The street light is up here. So we want to find, if you were to label our triangle, we call this A. So this would be A. This would be C, and this would be B. We want to find A. So we are given this would be, now this would be B. We're given B is equal to 8 feet. Theta is equal to 75 degrees. And we have to find A. Now, what we should do next is to label the sides of a triangle. So this is my angle, 75 degrees. The side opposite the angle that's given will be A. So this is my opposite here. So I'm going to remove all these here because they're kind of to make it look. So opposite side. The ground level will be referred to as the adjacent side because it's adjacent to this angle. So this is the adjacent. So we need to find A, which is the opposite side. So then I'll go to my trig ratios. And I refer to my trig ratios here. I need to find A, which is the opposite side. So I have B, which is my adjacent side. So adjacent, so ADJ here. And we have theta. So we need to find the opposite. So I go to my trig ratios and find where there's a match of adjacent and opposite. So this opposite and hypotenuse, so sine will not work. Adjacent and hypotenuse, cosine, no, that will work. What work now is the opposite and adjacent. So is tangent. So we'll use this ratio here. So we say tangent theta is opposite over adjacent. So we have tan. Now from here we have tan 75 degrees. The opposite we don't know. We call that B. And the opposite is given, B, which is 8 feet. Oh, no, opposite isn't given, so it's A. But B is 8 feet. So opposite over adjacent, so our adjacent is equal to 8 feet. So I need to find A. So to find A, I multiply 10 simplified by 8. So A is equal to 8, 10 simplified. When I go to my calculator, and I typed in exactly what I have here. I put 8, 10, simplify, close bracket. And that would give me a measurement of 29.86 feet. So the height of the street light, so the height of street light is 29.86 feet. So I need to find, so this becomes 29.86 feet. So let's recap. We were given that we were asked to find the height of a street light, and we're given the angle of elevation and the distance from the observer to the base of the street light. And we used the tan ratio to find the height of the street light. Okay, let's look on to example 2. In example 2, said you have a 6.12 meter long conveyor belt. It reaches a height of 1.2 meters at its higher end. Determine the angle of inclination. Now, I want to look at what I mean by angle of inclination. Now, angle of inclination is similar to the angle of elevation. Oops, that's wrong. Better. So the angle of inclination is the angle between the x-axis, this is the x-axis here, and a line. Or if you're the observer, it's from the horizontal going upwards. So it's similar to the angle of elevation. Think of angle of inclination as angle of elevation. So it's, if you look at the example of angle of elevation, you will see it's the same from the ground going up. The only thing you're looking at inclination is always from the ground level, or it could be the observer's point of view going upwards. So that's inclination. So let's go back to our question here, and this will make more sense once we do this question here. Now, they said you have a 6.12 meter long conveyor belt, and which reaches a height of 1.2 meters at its higher end. So we have something that's inclining, or it's traveling at an angle, a conveyor belt. So to illustrate that, so we have our ground level here. So our angle, so this is a conveyor belt is going, which is 6.12 meter long. So this is your conveyor belt, 6.12 meters long. That's what it says here. It's a conveyor belt. It reaches a height of 1.2 meters. That is a higher end. So this is 1.2 meters. So this is our angle of inclination. So you're asked to find this angle here. So what are we given? Let's just say we're given. So let's label the sides. So this side here would be the opposite side. This would be the adjacent. And this would be your hypotenuse. So we're given the opposite side, which is 1.2 meters. We're given the hypotenuse, which is 6.12 meters. And we asked to find theta. So we'll go to our trig ratios again and find when there is a match. So we have opposite and hypotenuse. That will give us the sine ratio. So we'll use the sine ratio. We sine theta is equal to opposite over hypotenuse. Then we substitute the given values into our trig ratio here. So we have sine theta, we don't know. Opposite is 1.2 divided by the hypotenuse, 6.12. So opposite over hypotenuse. So now we're going to use our calculator to find. Now, whenever you're finding the angle, you always use this second button, or in some calculators, you use the inverse button. So this will give me, I'll press my second button. So let's try to my calculator here. And I make sure I'm always in degree mode. I'm in degree mode here. So I'll press my second button, sine. Then it's 1.2, say my bracket here, 1.2 divided by 6.12, close bracket. Then I press my equal sign. That gives me an angle of 11.31. So 11.31 degrees. So just remember, the angle of inclination, it's another way of saying the angle of elevation. It's always from. Okay, the third example, the angle of depression. So here we have an angle of depression from the top of a viewing tower to an animal on the ground is 30 degrees. The height of a tower is 25 meters. How far is the animal from the top of the viewing tower? So let's look at angle of depression. So angle of depression, it's always an outside triangle, generally speaking. So if you're looking, go back to my initial angle of depression. So your point of view here, horizontal line, the depression is going down. So it's always from your point of view. And I'll show you, let's say this would be, in this example, we look at the top of a building. So it will be looking straight down, going down this way, angle of depression. So let's see how this work out in this question here. So we'll imagine this is the ground here. And we have a tower. So this is a tower. So the angle of depression from the top of a tower, so ground is 30 degrees. The height of a tower is 25 meters. So this is a tower here. So this is 25 meters. Now, this is your eye here looking. So now you're looking straight horizontally. So the angle of depression is the angle coming down this way from your, and they said this angle here is 30 degrees. So if this angle here is 30 degrees, this will be 60 degrees. And this is the alternate angle here. So this angle here would be also 30 degrees. Because you're alternating angles. Another way of looking at it, if you were to construct here and make this into a rectangle, this would be 60 degrees. And we know the sum of the angles that are perpendicular is 90 degrees. So we have the height of the tower 25, the angle of depression is 30. So we have all of the angles in this triangle. So we can use any of the trig ratios to find this. But let's label it. They tell us that the animal is down here. So this is for animals, A for animal. Right. So we're asking you to find how far is the animal from the top of the viewing tower. So we're looking to find this height here, this length, sorry, this distance here. So essentially it asks me to find the hypotenuse. So let's label this side. This is the hypotenuse here. This will be the opposite side. No, I'm using this angle here. Now, if we were to use this 60 degrees angle, this becomes your adjacent side. So, but I'm going to use opposite side. I'm using the reference angle. So I'm going to say given theta is 30 degrees, and we have the opposite side is equal to 25 meters. We asked to find the hypotenuse. So there we go to our trig ratio again. So where do we see opposite and hypotenuse? Opposite hypotenuse is sine. So we'll use a sine ratio. But sine theta is h by p. So then we substitute the given values into our trig ratio. So we have sine 30 degrees is equal to the opposite, which is 25, over the hypotenuse we define as x. So x will be equal to 25 over sine 30. Now I go to my trusted calculator again. And in this case, because I'm trying to find a length, I'm not finding angle, I don't have to use a second button. I go directly into my calculator and enter the values given here, which is division. 25 divided by sine 30 equals 50. So that's 50 meters. So the animal is 50 meters from the top of the viewing tower. Okay, so just remember this is your angle of depression. Okay, your assignment for today is assignment 6, application of the trig ratios. There are 7 questions, and you wouldn't mind to go through each one of these, go through each one, and tomorrow, or the next lesson, I'll take up these questions.